It will be slightly more complicated. So I'm going to use examples with small numbers first for you to get the concept. When you get the concept, we go for a generalized format. I have got two functions here called G and F. So we're going to look at this thing called a composite function. So you have two alphabets. The alphabet that is closer to X, you think of it as you do that operation or do that function on X first. So the one closer to X is the first function. We will be applying two functions sequentially, one by one. G goes first, followed by F. F is the second function, one by one. What do I mean by one by one? Let's say you only have one function called G. How does that start from? G domain is more than -1. So your X values are all -1 and above. We call that domain G. So domain G in terms of values, this is the set of values. We recall the notation from -1 to infinity, inclusive of -1. You apply the G function. G function is doing an addition of 1 to all the values to get to this next set called the range. So range of values is now 0 to infinity after you add 1 to all. This is whatever we have done last week. Now the difference is this current set of G now for range G will in turn become the new domain for F. What does it mean by new domain? Because I am now going to apply the F function next on this new set. Whatever values is now in the intermediate circle, it will form for me a new domain. Domain means you start. Okay, you start from the set. So this forms for us a new domain. When I apply the F function, it means every value we subtract 2. So I'm going to subtract 2 from that 0, we get -2. I continue to subtract 2, we get -1, 0, 1, and so on. You are thinking of the first range becoming the new domain on the second function. And that last set, we call this the range of the entire composite function fg. It's written as range fg, no longer as range f. Okay, so think of a composite function as you're doing two functions sequentially. You start from g and then you continue to f. It is often that we write in a mapping notation. What is this mapping notation? Means we say we start from domain G, you apply function G. Apply function G is to write the G just above the arrow. And here we get to range G. From range G, remember that this forms a new domain for F. I just want to keep emphasizing this for the start today. Use this as a new domain for F so that you apply the F function to get range Fg. I made one change in the equation on the top and bottom. Let me highlight where the change was made. Initially, I defined the F to be positive values. In the bottom, I made that one change only. I changed the domain of F to be at least 1. I made one change in the equation. Now, let me write here, this was changed. Okay, versus the above equation, I made that change there. Okay, it's important to see this example to understand the concept. Now, what is going to happen? I didn't change G, so I don't expect the front part to change. G is completely the same. So from domain G, I will get to range G. But now look at this domain of F. This is domain F, in case you forget. Domain F is only defined for x at least 1. Domain means what values of x it was defined for. So this value 0 has got a problem. Because if I would like to apply f, I cannot apply f for 0. 0 is not defined for f. We only know f's equation from 1 onwards. So this number is stuck. It's no good. I only know how to do from 1 onwards. I can do that same mapping, where f function is trying to subtract 2 to all the numbers. So I get -1, 0, 1, and so on. I could do it for every other number, just not for 0. But this is no good for us at all. At the intermediate stage, 0 cannot be mapped. I cannot move 0 through the function f. This is bad. This is undesired. Then we understand more. Why is it bad? Can I write down exactly what I mean by bad? Why is it undesired? It is bad because this set, this big set here, which is range G, is a bigger set than domain of F. This yellow set is domain F. The blue set, let me highlight correctly. The blue set is range G. The range of G has got values that are not inside domain F. It is very bad for us because I cannot apply the function f anymore on the intermediate step. Okay, so let me write down in words. What is bad? Range G is a bigger set than domain of f. If you get that bigger set, we will be stuck because we will get a certain value that I cannot define for f. So we need to think on the contrary, which is what we will be using throughout this chapter. What is good then? What is good will be the opposite. I want range G to be a smaller or an equal set compared to then your domain of F. In terms of set notation, this smaller set or equal to set, mathematically, you're going to write range G subset domain F. And the phrase that we look out for us to apply this formula is the word exists. This is for the function fg to exist. Exist means to even be appearing or to be defined. If you want fg to exist, you need this good part where you want range g to be a subset. Okay, so I'm trying to use this example to explain to you about this small subset. But generally, we will see in equation. I want to show you what we need to memorize or remember. Okay, let's go to the next page. Show you the general steps. So this is with a simple example. Again, let's recall if I have this fg function, who is the first function? It's always the one closer to x. Think of it as gx on x. G goes first, f is second. So this whole setup looks like this diagram that I have drawn. From domain G, I apply G function, I will get to range G. Range G is this purple part on my screen. This is range G. We must always ensure range G is a set inside domain F, a smaller set inside domain F, so that you can apply F function on the entire range G. Let's write down in terms of mapping again. This kind of setup, we always write something like this. Domain G, apply G function to get range. From range, apply F on this range to get range FG. And I emphasize third time for today, this range G is the new domain for f function. You're applying f not on the entire set. Okay, we don't care about what is domain f. We are going to apply f about on range G. So some properties that we need to further know. What is the domain of the whole setup? What is domain again? Domain is where you start from. Where did you define the x to be? So in this whole diagram, where did we start? I started from domain G. This is the start point. I started from domain G. So the domain of FG is actually just domain G, the place where you start. Note that there is no such property because usually I go through this and students start to assume the following statement. There's no such thing as range FG is range G. It doesn't work. It's not like you switch the word domain, it will become range. Okay, it's not like that. We will see properly in examples later how to find the range, but let's not assume something like that first. Okay, in short, you should remember it's always domain on the first function. And second one I've covered with that example just now, if they use this phrase exists, composite function exists, is to check for range on the first function is a subset for domain on the second function. Range first, subset domain second.